Hello.
Yeah.
Well, this talk is not going to be precisely about macros. It's going to be about the way you could easier manage and package and distribute them in regards of IntelliJ support. As far as you know, probably IntelliJ has its own type checker, its own parser, lexer, type checker, and whatnot. And from these, several problems arise, one of which being not able to type check macros because they are too tightly coupled with ScalaSphere internals. But this is not actually the only problem we can solve with the approach that I'm going to show. Sometimes several libraries and library authors are willing to provide external support for their libraries, like custom inspections, quick fixes, and so on. Or in several cases, the code you're working on cannot be, public. And enabling some additional support in IntelliJ will require you to actually upstream the support into our plugin, or you can build your plugin based on IntelliJ Scala plugin and use it internally. But that's pretty much the same thing. And in case you wish to upstream your changes, the process could become a little bit complicated in terms of, you have to submit pull requests, and like we have to look it through. We have many pull requests. We have lots of things to do apart from reviewing pull requests. So this can get a little bit long in terms of time. Last year, I think, we tried to solve this problem by a slightly weird approach. The approach was, bundling your code that extends Scala plugin. You would bundle it into your library jar, and alongside with some meta information, and it will IDE will load it, scan, and compile in load it in runtime without the need of explicitly publishing the plugin into the repo and so on. Well, apart from that, we obviously have lots of extension points in both in the IntelliJ platform and in Scala plugin itself, which will allow you to create a plugin which depends on the Scala plugin and put your necessary functionality in this sub plugin. But it still, requires lots of effort and time to set up and get going. So regarding the first one, the source-based injectors, they would require you to develop a standalone project based on the Scala plugin. It would be basically, using the extension points which I mentioned in the previous slide. Extension points are basically interfaces that you have to implement and declare in a certain XML file. So you export it so that IntelliJ sees them and is able to load it and attach to the running process. So in this example, you would basically create those extension points and bundle the implementation classes inside your library jar. Unfortunately, this will allow you to spare some time by not needing to upload and publish your plugin into the repo, follow some formal process of approval and so on. Unfortunately, this comes with many drawbacks, such as the process is a little bit complicated. You need to pull the sources from your library, and IDE needs to compile it, verify, and so on. It turned out to be not exactly the most reliable thing. So far, the only viable approach was to create a plugin, an external plugin, which has a hard dependency on Scala plugin. So basically, you're distributing the ordinary thing. But we have learned lessons from the previous failed approach, and we now reconsidered the way we are willing to load it. So basically the only thing we've changed is that now you can, instead of bundling the extensions for Scala plugin inside the jar file of your library, you simply create another standalone library inside your organization, which I will show the examples later in a few minutes. That's just the overview. So you have your main library, for example, like shapeless, cats, whatever, and you, as the author of the library, develop those extensions for the Scala plugin, and you basically publish another library to your organization, which is has a slightly different name, and IDEA then scans for available libraries with the extensions, downloads them, and attaches to itself. So this eliminates the need to modify your existing libraries and allows you to publish support for already released things, such as old versions or unsupported libraries and whatnot. So far, what you can do with it. We have several most common interfaces which you can implement for basic reasons like providing return types for a white box macro, or like some macros do not really play well without being fully expanded. So unlike the previous thing, the typable interface, it will allow you to like not just infer the return type of a function, of a method, but also like transform the ASTs like the original macro does. So IntelliJ will understand what you're trying to do by using our own API. So another thing would be members injector. This is mainly used for macro annotations. So when you do some extensive code transformations, for example, adding methods, adding fields, adding superclasses, and so on, you probably want to use that one because it allows you to do all that things. And for example, we have a bundled inspection, which is a way of providing custom inspections without modifying the Scala plugin itself. So a quick overview of how, in general, you would do it. Firstly, you need to set up the project. And setting up the project for development for IntelliJ would be just as easy as adding an SBT plugin. Oh, I don't think you can see it properly because the screen is a little bit high. Can you see it? So yeah, we have a specific plugin, SBT IDEA plugin, which basically what it does is it allows you to provide it with a version of IDEA that you're gonna that you wish to develop upon. It downloads it, attaches all the necessary jar files. Basically, the only thing is currently lacking is packaging the artifact in a zip file, which you have to write yourself for now, but this feature is definitely planned. So after adding the plugin dependency for your build SBT, well, this is like the basic template. We're going to take. Can you actually see the topmost lines? Because, yeah, judging by the lack of response, you can. So we are going to be basically taking shapeless and developing support for the generic macro, that thing that transforms case classes into H lists and vice versa. So what you need to do is to specify the name of your library and a suffix. A suffix, the default suffix would be IJX, and you leave the name of your company and version same as the library you're developing extensions for, well, you still can provide a suffix for the version. And IDEA will pull the latest version of your extensions library for your given library, which you want to support. I know I'm mentioning the word library too often, just don't want to confuse anyone. So, apart from setting up the basic SVT project, you need to define a key, IDEA build, which is basically a string key, and you specify a version of IntelliJ which you want to build against. In my example, I'm going to be taking one of the latest EAPs, this one, or you can just omit this key and it will automatically download the latest EAP anyway. So you can also specify IDEA external plugins, for example, to download Scala plugin. It will automatically download and attach it as well. Yeah, unfortunately, the current version of the plugin is not yet uploaded even to the nightly channel, so instead of using this key, I'm going to manually depend on the plugin artifact. So, so far we've set up the project. Now we need to basically start coding. Oh, so I'll state the problem. We have a case class, and we have a generic macro. And what it should do is to provide something like an age list, this one. You can barely see it, but anyway, some shapeless magic. Unfortunately, in IDEA, it enforces nothing, which is not good. That's the thing we're going to fix. We're going to fix it by extending the interface that I mentioned before, the Scala macro typable. Yeah, I already have an example what it should do, like to transform case class into this long signature of nested parameterized types. What we need to do, firstly, we need to define the context in which this extension should run and transform your code. Our context would be shapeless generic, and method would be materialize. Yeah, there we go. So this method just expects you to provide it with some case class with a reference to method name and containing class in which the macro resides. It's pretty straightforward. So, and the meat and potatoes is in the check macro method, which takes macro function and context of macro application. This is basically the place, the method invocation. It's like the method call with arguments. Yeah, and returns sctype. Sctype is a IntelliJ representation of type system of Scala. If you are familiar with Scala Reflector or Scala Meta, it would probably be slightly easier because they also have the tree structures for types. So we firstly need to check that you know, the expected type is not empty at the place of the call, and if it's empty, we just do nothing fast. So just return. So then what we need to do is to extract the target type, which would be the shapeless generic awks and whatnot. I have several utility methods to do that. Yeah, and since we don't really have much time, I'm just typing really fast, as you can see. One line per like 2 seconds or 1 second. All right. Apart from extracting the target type, we also need to extract fields from the case class. And that's what we're gonna do. I have several utility methods to do that. They just do what they state to do. Fields are just sequence of types, because that's the thing we need. So we also need to add some other boilerplate, like target type. Oops, wrong one. The representation string, of the hash list and the generic string itself. And that's basically it. And now only thing we need to do is to generate the actual types for the Scala plugin, which is done with the ScalaSphere element factory. It's basically a class which generates types from strings, classes from strings, you know. So fairly easy. All right. So the next thing we need to do, we've implemented the extensions, and now we need to create a manifest to export our extensions so IntelliJ would see them and able to load them and use them. So that's what we're going to do. We need to create a file called IntelliJ compat XML. Oops. I don't think you see this one with a name like that. We have already published a DTD for the XML. It will be slightly more presentable. The actual I actually already created a web page on our wiki where you can look that up in more details. I'm just showing you currently where to look because we're quite limited in time. If you go to our GitHub repository and see the wiki, I've just updated one of 3 pages. It's not going to be very difficult to find, I think. So yeah, and the extensive manual will be up like in a few hours, days maybe. So what we need to do is to specify in this XML what we firstly the common names, versions, and so on. That's pretty straightforward. We will call this extension a shapeless support and provide some description and version, which should be the same as the library you're developing for, but that's not a hard requirement. So the next thing we want to do is to specify which versions of IntelliJ to run to attach these extensions to, because our API might change, and even plugins, official plugins, are not compatible with all the versions. So we need to define that. To define that, we need another section which basically specifies the start build, the since build, it's the earliest version of IntelliJ, which you want to use, and the latest version, which you will develop for. And then you just specify a list of extensions. Extension contains just the interface, is like one of those interfaces that I showed you. There will be more, although, so you're not really as limited as I'm showing you currently. And in the implementation, you provide actual class, which we've just developed. Oops. This one. This one. Why doesn't it? All right. It's generic. Doesn't work. Oh, the projector broke my graphics, which is really unfortunate. Anyway, so yeah, we can also provide an optional description for the extension that will show up in the settings. And that's basically it. We have coded it, and hopefully it will build and publish. To publish it, you just invoke, for local testing purposes, you would just do sbt publish local. I think I have it somewhere. Publish local. All right. Hopefully it will compile fine. Still wondering what's wrong. It works fine. Yeah, success. All right. So let's go back to our example. And we press SBT refresh, so IntelliJ will rescan for the extension libraries. Whoa, we don't need that. So the way IntelliJ looks for extension libraries, it's basically taking the organization, the library name, and the version, and it transforms it via different patterns. Alright. And searches for the changed libraries. Where did I publish it? 12? Oh, the one important thing, which I'll probably fix quite soon, is you need to disable the cross-building suffix. Cross paths? False. But you haven't seen it? Like, you didn't see that. So far we need this, but you know, in the actual release builds, you do not have to disable this thing. Right, we'll just try going back to the presentation mode and refresh the project. This takes a while with our internet. Alright, now it's showing me that there are extensions available, and for a given library, since you see I'm depending on shapeless. And we've just published shapeless IJX. So IntelliJ actually like used Ivy. It used your resolvers defined in your SBT files. So whatever repositories and resolvers are reachable from your project will be reachable from IntelliJ, and so it's able to, you know, actually download and resolve the necessary dependencies. So Slack. Yes, and if I say that yes, I want to enable the extensions, it will actually load it, and they're gonna show up in Scala settings in the extensions tab. Woohoo! So that's just the thing we just wrote, and you can see that it provides a shapeless materialized generic with a description. Alright, apparently I forgot to actually provide the description, but never mind. Let's see if it works. We have my Scratch file somewhere. Oops, there, generic, gencat. And voila. I'm not sure you can see that. Can you? Should I do it a little bit lower? Like that. Yeah. Hopefully this is a correct type. String int ashnil. Yeah, string int ashnil. Yeah, it's fine. So that's basically the quick demo of what you can do. As you've seen, I haven't published any plugins to our repository. It's just within a single project, your project. So you can basically, the release cycle is very narrow, is very short. So you can basically test it without uploading anything. As soon as you're ready, you'll just go for it anyway. Yeah, that's it. And speaking of the way IntelliJ searches for extensions, this might be a little bit complicated, as we have patterns that IntelliJ takes and transforms your library names. For example, substituting the given macros for like organization. That in case of shapeless, that would be com, choose. Never understood how do you pronounce that. We don't have miles today, unfortunately. All right. So it substitutes the macro with the actual library names, and in this case, for example, it just adds a suffix of -ijx and a version plus. If you're familiar with IV pattern matches. That means that it will match to any subversion, basically any suffix on a version, and find the latest one. All right. So the next default pattern is same thing, but for the libraries we provide, or the extensions we provide. I mean, that's just if for the people who are not really eager to develop them themselves, will eventually make them, hopefully. Yeah, so you are free to add your patterns, or even like specify concrete versions, concrete libraries that you want to pull as extensions. For example, like org scala meta, percent scala meta, percent 1, 2, 3, yeah, and so IntelliJ will always search for the given extension, regardless of which libraries you have attached. I don't really know why we would need that, but you can do that. All right, so that's basically it. We have 3 minutes left. I think I've shown you pretty much all the things I intended to. I guess it's time for questions. If you have some suggestions regarding of what you are expecting from the API, you want some custom extension points, you can just talk to us. Yep, you probably know where our booth is, or you can just talk to me after I finish the presentation, the talk. So,
Thank you very much.